small outback petrol station receives a weekly delivery of petrol. The volume of petrol sold in a week, X, in units of 10,000 litres, is a random variable with probability density function as given here. It's shown in the graph below. Determine, using appropriate units, the expected value and variance of the amount of fuel sold in a week. Well, the expectation for a continuous random variable is always equal to the integral of x f of x. So what we're going to have is the integral from 0 to 1 of x, so x times that function, let's put the x in here, 5x, 1 minus x to the power 4 dx. Now it's calculator assumed, so let's do this on the calculator. So we have the integral from 0 up to 1 of 5x 1 minus x to the power 4 dx, and that gives us 0.16 recurring. Now remember, that's in 10,000 litres. So if we multiply that up by 10,000, it's going to be approximately 1,667 litres. Now to get the variance of x is the expectation of x squared. Take away the expectation of x squared. The expectation of x squared is, instead of x f of x, it's x squared f of x. So we're going to have the integral from 0 to 1 of 5x squared 1 minus x to the power 4 dx. Take away the last answer squared, and we can calculate that. Now we can certainly make use of this, so we're going to do that, and we're going to just pop a squared in there, and then here we're going to take away this answer squared, and that gives us 0.0198. And in the Wace solutions, they've multiplied that by 10,000 and given that as 198 litres squared. I agree with the units. I'm not exactly sure that we should have multiplied that just by 10,000 because variance is a squared unit. Hey ho, that's their answer. And we don't really need to use that for the next part anyway. What storage tank capacity will ensure that there is only a 1% chance of running out of petrol in a given week? State your answer to the nearest litre. So what we're saying is that there's a 1% chance of running out. So that's just going to be at this end here. And so we're wanting the rest of it to be 99% essentially. So what we can do is we can do the integral from 0 up to some value c. I'm going to call it y actually. Of 5, 1 minus x to the power 4 dx. We want where that is equal to 0.99. So we can solve for that on the calculator. So we can do an action advanced solve, and then we can do the integral, and we'll take that integral, oh, I've got two integrals there, So we've got solve 0.99 is equal to the let's done it again. That's better. And I've got 0 to y of 5, open a bracket, 1 minus x to the power 4 dx, and I need to tell it that I'm solving for y. And we'll execute on that, and it gives me 0.602. So y is equal to 0.602. And again, remember this is in 10,000 litres, so the required is going to be 60, and if we can take the number over here, 6019 litres. When the petrol is delivered, it is pumped into the storage tank. The rate of change of the petrol level in the tank, h of t, measured in meters, at time t, measured in minutes, is given by the following. Determine the height of the storage tank if it takes 20 minutes to fill. So this is a total change from rate of change. We're wanting h of t, and we'd be filling for 20 minutes, so going from 0 to 20. And our function is 5 over 2t plus 3. We don't have to fiddle around with the 0 and the 20 because 20 minutes to fill and the time was in minutes. So it's going to just simply be that. And once again, we can just do that on the calculator. So we're going to go from 0 up to 20. And our function in here is 5 over 2, let's use x, plus 3. And then we'll just go dx. And it's 6.66 essentially. So 6.66, and the units were meters.